We will now analyze this motion of the spring. If we suppose we have a spring and this is the x direction, and this equilibrium position of the spring would be here. So we pull the mass up to here and let it go. So it will go down and up, and it's going to oscillate between these two positions. So when it's right up at the highest point, then it's at that instant we start the time. So x will be the maximum value, and as it slides down, the x will get smaller, then go negative, and then as it starts going back up again, x will become positive. And well, x is going to start getting bigger, and then it reaches the highest point and keeps going up and down. So it keeps oscillating here, and this is a cosine function. So we can see that this is a cosine function. And here the phi is 0 because for t equal to 0, x is x max. So this is 2 pi when t is 0, or 0 or 2 pi. So when t is 0, this whole thing is 0, which means phi is 0. Now we look at the velocities. So when it's at the highest point, it's for an instant it's stationary, and we can also see that if t is 0, we put t equal to 0 and phi is 0, so sine of 0 is 0, and so the velocity is 0. And then when it's at the lowest point, that's here, then that's pi would be 180, the angle would be 180 degrees or pi radians, and for pi radians the sine would again become 0. So this is the point when it's at the lowest point. So the velocity is 0 here and 0 here. Now in the middle, when this is 90 degrees or pi by 4, this will be 1. So we have a maximum value of velocity when the mass is right in the middle. At that point the velocity is maximum, and because it's going down, it's negative, and when it's going up over here, it will be positive. So the velocity is 0 at the top and bottom, and it's maximum in the middle. Now to look at the acceleration, we look at this equation, and the curve is here, and we see that these two are both cosine functions, but this is with a negative sign, and also we have a magnitude difference. So the negative sign means that when it's positive, the acceleration is negative. So at the highest point, when it's here, the acceleration is going to be downwards. If this x is positive, the acceleration is downwards, so it's negative. And when x becomes 0, at that point this cosine would be 0, so this cosine would also be 0. There's no acceleration when the mass is right here. So the acceleration is maximum here, and then again when this reaches the maximum value here, the acceleration becomes maximum. So acceleration is maximum here and here, and the acceleration is 0 here. The velocity is 0 here and here, and the velocity is maximum here. Now in the upper half, the force is downwards. So in this part and in this part, the force is downwards, and so the acceleration is downwards. In the lower part, when it goes below the mean position going up, the x is negative, the acceleration will be upwards, because from Hooke's law we have F equals minus kx. So when x is negative, the force is positive, and so in this part the acceleration is positive, and when it's in this part the acceleration is negative. So in the upper half the acceleration is downwards, in the lower half the acceleration is upwards.